Okay, welcome to Math with Doug. It is geometry. We're going to do a whole lesson just about triangles. It's amazing how I'm able to explain all of this without moving my lips, eh? And that's because it's actually me who's talking and not her. Okay, that was a pretty lame joke to start the lesson with, but it'll do. She's getting very shaggy. We're getting close to that magic date when she gets groomed, and suddenly I can see her eyes again. Okay, I'm putting you down. Lie down. Stay. The dog's job is to do nothing to bother me while I teach triangles for an hour. And we'll see if it's going to be an hour. I'm kind of timing it while I go. I think I have enough examples. When you draw things, it takes longer. What else is going on? It's still cold. I keep on not talking about the weather lately because it just gets to be the same message every week. I will say that Vanessa just made me, that's the bunny, she just made me go out to a storage thing that I built for bicycles on the side of the house. I had to climb through a snowbank to get to it. It's all tarps and wooden structure. I had to break the tarps free, crawl inside to get two bike helmets, grandchildren's bike helmets from their bicycles. Because I innocently thought bicycle helmets really need to be just put away for the winter. But it turns out when grandchildren do certain field trips that involve tobogganing, they're told, bring your bicycle helmets. And I had to go and get the bicycle helmets. So I just finished changing my clothes. I had to change my socks and my trousers because they were soaked from crawling around in a snowbank. So that's how I feel about the weather. The shirt is Barcelona. I know you've seen it before. I really like Barcelona, so I wear a lot of their shirts quite often. And oh, what a great advertisement. UNICEF, a charity that benefits children, as an advertisement on a sports jersey. Good idea. Okay, now let's get into the math. It's triangles. We're going to draw triangles with all sorts of different sets of instructions, and it's fun. I love this. I used to have to do it a lot. And then they changed the books that I usually teach math out of, and the students didn't get to draw triangles for marks on exams anymore. So I never find myself explaining this anymore, but I always did like it. So now I get to do it for this, this lesson. And the first one is going to be a 20-inch side, a triangle with a 20-inch side between two angles. I'll just write angles of, and the angles have to be a 38 degree and an 80 degree. 38 degrees and 80 degrees. Let's make sure this all fits into the video rectangle okay, and it does. Okay, so one of the things that's fun about this is I have all this space, and it doesn't really take too much space to do this. I am making 20-inch side. I need it to be big. It's a lot bigger than I would ask a student to do on a piece of paper. But it's a chalkboard. So 20 inches works. So here's my 2-foot long ruler. And I'm going to start by drawing the 20-inch side. Very frequently I will start drawing a triangle by drawing a side, because it's hard to draw an angle first. You draw an angle using a side and drawing another side. So you just draw the side first. That's what I'm normally going to do. 20 inches, there we go. That's going a little crooked, let's fix it. 20 inches is to here. And I will label it right away. 20 inches. Okay, between two angles of 38 degrees and 80 degrees. So this is not especially difficult. We realize that we have only one of the three sides given to us and two of the three angles. But I think the students already know some tricks about, well, is there a way to figure out what the third angle would be? I know that you know how to do this. We will be doing it. But first, I'm just going to get busy drawing the two angles. So I have a 38 degree and an 80 degree. I can put them on either end of this. I can draw them above the line or below the line, but I'm going to go above the line. And it doesn't matter if I put the 38 degree one here or over there. So I have all this flexibility about how I do it. And that's cool because when a bunch of students do it, the same instructions, they can end up with slightly different looking drawings. And then thinking about why the drawings look different promotes understanding of the math, which is a good thing. So a 38 degree angle, I'm going to measure that with my protractor. 38 is right there, I'm making a mark. I want a straight edge, so I'm going to use the long ruler because I realize The other one's going to be 80. I need to draw this line fairly long. It's okay to draw it longer than you actually need. Draw it nice and long. I think this will be long enough though. And I will label this right away, 38 degrees. Now I'm getting the protractor again, and I'm drawing the 80-degree angle. So that's over here. Other side of protractor, other set of numbers, 0 dot baseline, 80 degrees is here. And then I need a straight edge, and this will be long enough. Am I in the way? I guess. But I should be able to finish my triangle. Label the 80 degrees. Now the rules that I'm used to are that anything they gave you, you should label. But the things they didn't give you, you don't have to label. Rules could vary depending on who's giving the instructions. But I think students would be able to give all three angles and all three sides anyway by applying their knowledge of geometry. So, just to get into that just a bit, we can figure out what the third angle has to be by subtracting from 180. The three internal angles of a triangle always add up to 180 degrees. So 180 minus 38 minus 80 is 80, 118, 62, isn't it? I'm learning my lesson from recent mistakes while doing these lessons, so I'm going to make sure. Chalk dust on the calculator. 180 minus 38 minus 80 equals 62. I'm right. So therefore, if I needed to, I could label this correctly. It's going to be 62 degrees. And I never drew that angle, did I? So I can also check. I can check that it ended up being 62 degrees by getting my protractor and taking a quick look at this and saying, oh yeah, that looks like 62. I like this. What I did worked. It's nice to know that you're doing something that works. What else is there to say about this? This is an acute triangle. We have covered acute angles, right angles, and obtuse angles. But now we're talking about acute triangles, right triangles, and obtuse triangles. They all exist. So the three words have a slightly different definition depending on whether you're talking about an angle or a triangle. So an acute triangle is one where all three of the internal angles are between 0 and 90. So is there anything else to say about this? Not really. Let's move on to the second example. That took almost 8 minutes, but of course that included the preamble about the snow and the wet pants and the dog and the this and the that. So that means we can do a lot of examples, and that's what we want to do. First I'm going to take a sip of my fizzy water because I have been near a lot of chalk dust today. Vanilla cherry flavor. It's not my favorite flavor. Okay. Let's erase, but I'm not going to erase all these words up here because I can reuse them for my second example. So I'm going to erase the 20 inches and the measures of the two angles, and let's see what our second one is. Oh, I wanted to point out one other thing, so I will, even though I just erased. There's only one way of doing that correctly. The triangle I produced is the only correct answer to that set of conditions we were following. Sometimes there's more than one correct answer. And putting it differently, there's more than one correct triangle when given a set of instructions. And I'm going to talk about that here and there as we go through these. Second one is going to be an 18-inch side between two angles of 25 degrees and 108 degrees. Not very different. Really, I'm starting the same way, except I'm not drawing a 20-inch side. I'm drawing an 18-inch side. Let's take a bit more chalk into this thing. And 18. So that's there. So I'm doing it backwards, but it still works. Okay, so here's an 18-inch side. Same strategy. Nothing really has changed. Nothing changes between this and the last example until we get towards the end. So I'm setting up and I'm choosing, it doesn't matter if I put the 108 or the 25, I'm going to do the 25, which is here. So that's smaller measure for an angle. I'm going to draw a nice long line because I predict I will need it to be long. Even longer just in case. There. Whew. Okay, that's 25 degrees. Whoop. And over here I need to draw a 108 degree angle, which of course is an obtuse angle. Setting this up, 108 degrees is way over here. It's there, that looks good. And then I draw the line, the left side of the triangle. I will label this 108 degrees. I can figure out the measure of the missing angle by subtracting from 180, but I don't have to. This question didn't ask me that, but I'm doing it anyway. 180 minus 25 minus 108 is 47, equals 47 degrees. And again, having learned my lesson from recent mistakes, 180 minus 25 minus 108 equals 47. So this one's 47 degrees, and I could label it as such if I wanted. And of course, the side length, with the math that my students who are learning this lesson know, we don't necessarily know a way of calculating the two missing side lengths. But we have this amazing tool called a ruler, and if we drew the 18-inch side in these two angles neatly enough, then we would just be able to measure them and find out how long they are. So just for fun, I'm going to do that. So this is 47 degrees. This thing is 23 inches. And this thing, the side I mean, this side over here is 10 inches. Now, checking these angle measurements and side length measurements using some more advanced geometry, we might find out it's not exactly 23 inches. It might be slightly less or slightly more, and the 10 inches as well. And that's why there's always good to give an allowable margin of error when students are asked to draw things or measure things from drawings. Because if I draw this side 18.2 inches long by accident, which would be easy to do, well then it will have an effect on the measurements I get for everything else. But for the purposes of this exercise, that's good. Now, one other thing to mention, this is an obtuse triangle, because it has an angle that's between 90 and 180. The other two have to be acute angles. You can't have more than one obtuse angle inside the same triangle. It would be impossible, but we'll talk about impossible triangles later. Okay, so is there anything else to say about this? This is also a scalene triangle. Now I was thinking about this, and with this sort of instructions, you're nearly always, when you create an obtuse triangle this way, you're nearly always going to also have created a scalene triangle. It would take a little bit of planning, I think, to make an obtuse triangle that's not scaling. But I think it might be possible. I'm not even sure. Maybe I should try it, but I'm not going to try it during this lesson. Because a scalene triangle has, none of the angles are the same, none of the sides are the same. So we can see 10, 23, and 18. Clearly I'm not the same length, and 47, 25, and 108 degrees are clearly not the same angle measurements. But is it possible to draw an obtuse triangle with instructions similar to this, where you play around with the side length and the angle measurements, where you might end up getting two sides that are the same length or two angles that are the same length? I think it might be possible. Yes, I think it's probably very possible. If I have time at the end of the lesson, maybe I'll try it. Maybe I'll try and make it happen. Obtuse and scalene. What I'll do is over here in the notes that I have that you can't see, I'm going to write obtuse and with and underlined scalene. And maybe I'll get to that later in this lesson, or maybe I'll do it next week. I don't know. But this is finished, and it was fun. They're all fun. But you don't always get a side between two angles for your instructions. This is one of the reasons it is fun, is that they can give you quite a lot of different sets of instructions, and it makes your strategy change. And what you want is to become the sort of student who doesn't care what type of instructions were given. They know a strategy for everything. That is a strong student. I am going to erase the 18-inch and the word side. I have a reason. And both of these angles and the whole answer. And let's do a third example. An 18-inch side, so I'm doing 18-inch again just because it's kind of convenient when we're trying to do those what if things. What if we do this different? What if we do that different? So sometimes I like to keep some of the measurements because it makes it quicker to compare what we did this time compared to what we did last time. How is it different? So I'm doing an 18-inch side, but I'm writing it way over here because I want to write not between angles of, and I'm changing the angles. So I have 45 and 55. 45 degrees and 55 degrees. Okay, so not much has changed here. What I will point out about the previous example, I have to stop forgetting to point out things until after I've erased. That second example, like the first one, there's only one correct answer. As far as I know, there's only one correct answer for either of those two. If I'm wrong, you tell me, and you know, you can type comments or whatever and tell me, no, you're wrong, and this is why. I would want to have someone explain why they think I'm wrong, not just say, you're wrong. Okay, 18-inch side, not between angles of 45 and 55 degrees. How is that going to be different? And I will answer that partially by walking further over here than I did for the others, because I'm going to draw an 18-inch line. There's 18. There it is. And a little shorter there. But then over here I'm going to do it again. 18. Where is it? There it is. Trying to focus on these little tiny numbers on this thing. Okay. Not between angles of 45 and 55. That's a little tricky. It means that I can't put the 45 and the 55. I can put one of them though. I have to. If you think about that, you realize, well, if the 18-inch side, which I should label, is in the triangle but is not between those two angles, it means it has to be between one of those angles and the third angle we don't know yet. So I think I'm going to draw the 45-degree angle right here as my next step in my strategy. How am I doing for time? It is slow, all these drawings. It certainly slow me down. I'd like to do more examples, but 45, so I'm drawing that. I'm going to make the line longer than I need it, like I usually do, because I'm not always certain what's going to happen, and I don't want to have to go and get a ruler and make the line longer later. That would make the drawing take even longer to draw. Okay, 45 degrees. So the 55-degree angle has to be up here. It's the only other choice, because I can't put it there because that would disobey the instructions. So the third angle has to go there, but what is it? Well, I guess I should find out by using the trick that everyone knows, which I'm going to remind you of. 180, okay, I'm writing it kind of small. 180 minus 45 minus 55. I'll put the little degree symbols. That's 100. So it's going to give 80. The third angle has to be 80, so I can put an 80-degree angle there, and I'm still following the instructions, so I'm going to. 80-degree angle. Let's do this quickly. 80, that's here. And then, is this long enough? It is. So I'm going to get this, use this as a straight edge, or is it long enough? It's just barely kind of long enough. Okay. And I can finish labeling. I've answered the question. I didn't have to do it twice. But I'm going to do it twice because in the two first examples I said there's only one correct answer. There's only one triangle that is a correct answer for each of these questions. But this one, there are two correct answers. Let's prove it. If I do another one that follows these instructions, it means I have to put a 55-degree angle at one end of this. It doesn't matter which end, but I'm going to put it at this end. There's 55. And I'm going to draw the line longer than I think I need it again. And if the line I need ends up going right up here into the words of the instruction, that's fine. I always kind of like it when that happens, actually. Because it doesn't matter, you can still see the triangle, even if it went right through the words on the page. And then this has, well, this is the 55. That's what I just measured. That was 55. Let's make sure I'm not forgetting anything. 55, yeah, that's 55. So the 80 has to go here, because again, I can't put the 45 there because it would disobey the instructions. So I have to put an 80 here. An 80-degree angle, and that's here. This is not going to be long enough. So I'll get this thing and set this up like that. That'll do. 80 degrees. And you can tell just by looking that these two triangles are not the same size. But they both have an 80, a 55. This one has a 45 here. And yes, I can measure it with the protractor to make sure, but I already know it's going to work. And this has to have a 55, oops, over here. Okay, now you get to see an old guy and how long it takes us to pick up something off the floor. Okay, two different correct answers to this problem. And I don't think there is a third way of doing this correct. Remember, we could draw a reflection of this, and it would kind of superficially look different, but it wouldn't be different. A reflection of a triangle is congruent to the original triangle. So it's really the same triangle, it's just we found a way of pointing it differently. Or I could rotate it, and it's still the same. I can translate it, and it's still the same. So I think there's only two correct ways of doing this, and I've done both of them. That's cool. And these are both, of course, acute triangles. All these angles are between 0 and 90. So that is neat. What's my next one? Okay, careful. The instructions for the next one don't change very much from this one. But it's going to change something. Let's erase. I'm going to erase everything. There. And what are the instructions? An 18-inch side with angles of 50 and 75 degrees. 50 and 75 degrees. Doesn't look really that different than the last example and the one before. All three of those I had 18-inch side, but that's not really why. The first one, the 18-inch side had to be between the two angles that are given. Then the last one we did, the 18-inch side had to not be between. And now this one, it's not saying either of those things. It means either of those things could happen. So I challenge you to tell me how many different ways will there be of correctly answering this question. I'm just going to get into it. I'm going to draw an 18-inch side right here. Let's say I'll put it around here. Okay, 18-inch side. Label it. And 50 and 75. Okay, so it looks almost like the very first question I did, but that had the word between in it. It looks really tilty, but it doesn't matter. It looks horizontal to me. I say this every week. Let's just get off of that subject, Doug. You have flogged that horse. Okay, 50 degrees, that's here. I'll make a mark, but I'm just going to go right ahead and go to the other side and do 75, and that's here. And now I can get my straight edge and draw both of these at once. Didn't draw it perfectly, but it's pretty good. And this one, I don't care about how the end of that line. That's the line I drew longer than I needed it. I care about this mark and this vertex. Okay, so that's a 50-degree angle, and that's a 75-degree angle, and I have correctly answered this question. But let's do it 2 more times. So I'm going to draw an 18-inch line over here. 18, no, that's 16. 18. And double check that this is really 18. It is. Okay, and over here, I'm going to do it over here as well. 18. Okay, and I'll label both of these, 18 inches, 18 inches. So I'm going to do it again, but I don't want to just draw this triangle again, so I have to do something different. I think what I need to do right now is say 180 minus 50 minus 75. Those add up to 125. 125, yes. So therefore the missing one is 55. So I'm just going to go ahead and draw 2 more triangles without talking about it all that much, because I have a feeling the students can figure out what I'm doing. Okay, 50, I'll do 50, but instead of doing another 75 like that one, I'm going to do 55. That's here. Too small. Okay, over here, I did 50, 55, 50, 75. I'm going to do 55. That's here. And I'll mark 55. And the 75, do I need a 75? Yes, I have 50 with 55, I have 50 with 75. Now I'm going to do 55 with 75. Basically, I'm doing all 3 combinations of those 3 side lengths, now that I know what all 3 side lengths are. Degree symbol, degree symbol, degree symbol, degree symbol, straight edge. Let's draw a bunch of lines. Is that mark? I nearly lost the mark. No, I need that mark. I need this to be correct. And then I'll draw the arcs. So this one's quite different from this one, isn't it? And now this one, draw the line longer than I'll need it. Draw this one. It wasn't longer than I needed, it was exactly right on. That was just luck though. Arc, arc. So we can see this is 3 different triangles. This one's the smallest, and this one looks like, small, large, what are you talking about? I'm talking about the area. This one has the smallest area, and this one has the largest area. But all 3 of them obey these instructions. So this type of instructions, there are 3 correct answers. And that is kind of cool. Okay, just looking at the time there. What's next? Let's draw one where we know all 3 side lengths, and we don't know any of the angles. And of course, yes, all 3 of these are acute. I think most of the triangles, or all of the triangles I've drawn, have been scalene. Just to remind ourselves that these things exist. We have acute triangle, right triangle, and obtuse triangle, which I've already covered off. Well, I haven't done a right triangle. I have to do one. And there's equilateral triangle, isosceles triangle, scalene, which we've done, and the impossible triangle, which we discussed but didn't draw. And let's see how much of this I can cover. There's some pretty fun triangles to draw. Okay, this next one, we're not going to know any angle measurements. but we know all three side lengths, and the side lengths are going to be 16 inch, 21 inch, and 23 inch. And I'll just write the word sides there. So when I do this, I like to always start with the longest side, because when you start drawing this, you're not really sure where it's going to go. So to make sure it's going to fit on your page, if you start with the longest side and that fits on your page, well, the chances that the whole triangle will fit on your page are better. Okay, so a 23-inch side, which is nearly the entire length of this ruler. This is a 24-inch ruler. Let me leave some room. 23 inches. Now the problem about drawing a 16-inch side and a 21-inch side is that I'm not sure where to place them. I know that one end of each has to touch a vertex at each end of this line, but if I draw the 16-inch side and then draw the 23-inch and they don't connect, it means that I have to start erasing and fixing it. So what can I do? What I can do is take advantage of the fact that, as we all know, the compass can be used as a measuring tool. So setting up the compass on my ruler, which is tricky to show on a video, especially when you're also holding this in your hand, so I put it down. Okay, so one of the ends of the compass is going on the 0 of the ruler, and the other end has to go to either 21 or 16. I'll do the 21 first. There. So it's hard to show that, but the 2 points of the compass, which I do not want to squish now, are 21 inches apart. And this is going to look a little bit familiar when you think about all the angle drawing exercises that we did recently. And I didn't really, well, I might be drawing across my instructions, but like I said, I don't care. I kind of like it when that happens. I'm not sure where to put the arc, so I'm going to make a nice, big, long arc, and I'm pretty sure that I've got it covered where I need. Now that was the 21-inch side. I have to remember that because I can't really label it yet because I'm not really sure where it's going to go. But the other one is 16, so I have to do this again. Where's the 0? For the inches side of this thing, 0 is there. And 16 is here. That is now 16 inches apart. And I go to the other vertex, and I draw an arc that crosses the first arc. Now I don't have to draw this arc so big, because I can see where the first arc is, so I just have to make sure they cross. The point where the two arcs cross has to be the vertex that I need, the third vertex I need for this triangle. So I will get my chalk on there and connect that point to this, and get my chalk on that same point again and connect it to this vertex over here. And then I know that this was 21 inches. And this is 16 inches. And I'm finished. And I don't know what any of the angles are, because I don't have to know. I can measure them with the protractor. And maybe there are ways, geometry somewhere, someday, that we will learn where we could find those angles without having to use a protractor. But what can I do? When I drew these lines, I wasn't measuring. I was just using the straight edge. So what I can do is I can measure the lines and make sure, is this really 21 inches? And yes, it is. Is this really 16 inches? And yes, it is. That's a fun one. I always like the given 3 sides, draw the triangle thing, and don't using the arc, using the compass as a measuring tool. All of that's fun. How am I doing for time? Getting there. Okay, that's the 3 sides. Now, how about if we know just 2 angles? We don't know any side lengths. We don't know all 3 angles. We just know 2 angles. So I'm going to do one like that. It's kind of flexible. We have 62 degrees and 73 degrees. So I'll write angles of 62 degrees and 73 degrees. Now, of course, I know students might want to jump and say, 180 minus 62 minus 73. Yes, you can do that. But what about the side length? okay, there is not only 2 or 3 correct answers to this one, because I get to choose the side length. So long as I have a 62 and a 73 and the third angle that has to be a certain measure in order for the 3 to add up to 180, I will be allowed to use any side lengths I want. So I can choose a side length that's convenient to me. I've drawn a lot of side lengths between 16 and 24 inches. So I'm going to do this. I'll do this 24. None of the ones I chose so far was as long as 24. I had some 23s. I'll do 24, which is the whole ruler. So let's draw a line. Whole length of this ruler, that's 24 inches. I need a side. You can't draw an angle without a side. So I have to draw a side. I chose 24. A student can choose 4 inches, which would fit on a page better than this. This is not going to fit on most pieces of paper that you have. So one student might choose 4 inches and another student might choose 9 inches, and they could both be correct. So that means there are an infinite number of correct answers to this question. That's kind of neat. But I have to have 62 and 73 degree angles on this. And at that point, I don't actually have to, I can finish this without subtracting from 180. So I'm not going to subtract from 180 yet. Okay, so I need a protractor. It's kind of an easy one when you think about it. It's so flexible how we can do this. And you just get busy doing it. 62 degrees, that's here. And 73 degrees. I'm just doing both of these at once to save time. 73 degrees is here. This is going to be a big triangle. But when you choose the very longest side to start with that you can measure with your ruler, don't be surprised when you end up with a big triangle. So that is 62 degrees, and I will label it. And this here, I'm going to have to add to the length of the line. This here is good, but it needs to be longer. I want to complete my triangle. I think I have to make that line even longer. Wow. Finally, made the lines long enough. So the third vertex is right over here, and it kind of messed up my topic title. But this is a good triangle, and I have to label this 73 degrees. And I was able to do it without actually knowing the measure of the third angle, but I can of course calculate it. 180 minus 62 minus 73 equals 60 plus 70 is 130 plus, and 2 plus 3 is 5. That's 135. So therefore it's going to be, wow, 45. Such a common angle measurement that you see all the time in math situations, but it happened by itself because I didn't plan it. So that is a 45 degree angle up here. And I can measure it if I wanted to make sure, but I feel quite confident now that it's going to be 45 degrees. That's fun. Now, of course, a student could decide to make it much smaller. I'm going to choose a 5-inch side. Okay, this is going to be tricky to do on the great big chalkboard with all the great big chalkboard tools. But if I put a 62 degree, that's going to be here. And then if I put a 73 degree over here, that's going to be here. And then this straight edge is long enough for this. Oops, got a little crooked. And then this. 5 inches, 62 degrees, 73 degrees, and that's going to be a 45. So that's fun. Now I'm going to measure this and make sure it's 45. And I will be very, very sad if it's not, but yeah, that's beautiful, 45. Fun. So these two triangles, of course, are similar. They have the same angle measurements, but they don't have to be similar. They don't have to have the same side lengths. I have 2 correct answers, and there are an infinite number of correct answers to this question because the side length was so flexible. That was fun. Okay, another one. Time. I have used 39, almost 40 minutes. Where am I at in my sets of instructions? I'm glad I have 20 minutes left, because I had to get into this, I'm going to draw isosceles triangles now. So we'll just leave that little mess up there in the geometry title, so that I don't have to smear the title too much. But we have some workspace cleared off. What am I going to do? Two isosceles triangles with a 53-degree angle. L's a little messy, but whatever. Okay, it all fits. Let's just look. It's going to be hard for students to look at later. Okay, two of them. Why? Because it didn't say it's isosceles. We're going to talk about isosceles. Isosceles triangles have two sides that are equal, two angles that are equal. But the third angle doesn't have to be equal to the first two, and the third side doesn't have to be equal to the first two. So we have what we call the apex angle. So I'm going to do a little diagram. I'm not going to draw a 53-degree angle. I'm just going to draw any old isosceles triangle, and I'm doing it freehand, so it's not going to be perfect. But if these two sides are equal, and they're looking pretty equal, and these two angles are equal, and they're looking pretty equal, this angle that is not equal to the other two is the apex angle. So that could be, I could draw one where that is 53, and I would be able to obey this set of instructions. But I could also draw an isosceles triangle where both of these are 53, and that would also obey the instructions. So since that obviously points us to two different strategies, let's do both. And I will erase this messy freehand thing and get into it. Now, I didn't give any instructions about side length, but I'm going to try to choose side lengths where we don't have little teeny triangles that are hard for you to see. So to fit two of them, I'll put one of them over here-ish and one of them over there-ish. And I'm going to make the side length I start with. I'll go back to using 20-inch side. And I don't have to. The second one doesn't have to have a 20-inch side. But I'll just give it a 20-inch side, just because I feel like it. Just because that way I know the final triangles will have to be big enough so that people can see them on a video rectangle. Okay, so if the apex angle is 53, I'm not really sure what to do next. But if the apex angle is the one that's not 53, then I know exactly what to do next, which is to draw a 53-degree angle on each end. And I could do that over there or over here. I'm going to do it over here. So let's draw a 53, ooh, I nearly broke this thing. Let's draw 53-degree angles on both ends of this. That's like that. I need more chalk. Using the protractor as a handy tool to allow the chalk to come out, but not too far. And that's 53, and then I'm going to do it over here. 53. Straight edge. Put the chalk right on that mark. Get everything lined up. And again, I'm drawing it longer than I need to because the extra bit of lines that go outside the triangles are called construction lines, and they're fine. Fine to have in a drawing. I like seeing them in a drawing, actually. And then draw the third side. And I actually drew those fairly close to the length I needed. Now both of these have to be 53s. 53-degree angles. To be more clear about what I am saying. And that means that these two sides are equal. Even though I don't actually know how long they are, they have to be equal to each other. And the third angle has to be 180 minus 53 minus another 53 equals 74 degrees. Teacher who has learned his lesson. Yes, it's 74 degrees. So this is going to be 74 degrees. And I can measure it with the protractor. I have too many tools in my hands. No wonder I'm bashing things against the chalkboard wall. Yes, 74 degrees is very, very believable. For that, it works. That's great. And how long are the sides? Well, we know that I started with a 20-inch side on the bottom. These look like they're both going to be shorter than 20 inches, and I think that makes sense when I think about triangles. But all that matters to me really is that whatever length they are, I want them to be equal to each other. So let's measure them. Wrong end of ruler. Okay. That's about 17 inches. And that's about 17 inches. Okay. So they're equal to each other. And I could label 20 inches, 17, 17. And again, about 17 inches is important to say because of measurement error with both the protractor and the ruler, these angles could be slightly less or slightly more than 53. The side could be slightly less or slightly more than 20 inches, and therefore these two sides could be slightly off as well. But when they come really close, accounting for measurement error, you're proud. Okay, now we want another one where the 53-degree angle's up here. What do I do? What I have to do is I'll use a bit of space over here. 180 minus 53, but I'm missing two angles. The fact that the two angles are equal to each other, though, helps me. I'll take 180 minus 53 and I'll divide the answer by 2. 180 minus 53 is 127. Math teacher who learned his lesson yesterday. 180 minus 53 is 127. Divided by 2 is 63.5. Now, I don't want to try to draw a 53-degree angle up here. It would be very hard because I don't know where the sides are. So I'm going to draw the two 63.5-degree angles instead. Time 63.5 is right about there, and 63.5 over here is right about there, and then I get my straight edge. Something just almost happened. Okay, and the dog still asleep. Good for her. She doesn't let little math disasters bother her. Oh, that line should have been longer. Okay, and this one too. There, that's going to be long enough now, I think. Nope, still not long enough. There, now it is. Okay, so these are both 63.5-degree angles. And this has to be the 53, even though I never actually drew it with the protractor. I drew it just by connecting two straight lines. So and these should be equal. So I can test now. I'm going to see how long these lines are. That is about, hard to see, it's way up there, about 22.5 inches. And then this one, about 22.5 inches. Feeling confident. Rescuing the protractor that didn't fall on the floor. 53, is this 53? Oh yeah, that's pretty good, 53. Okay, so I drew two isosceles triangles that each have a 53-degree angle, and you can see how different they are from each other. Because whether the 53-degree angle is the apex angle or not can be calculated and figured out using all of this cool stuff that we know how to do. And we feel strong when we can draw things like that. Anything they give me, I'm going to be able to figure out a way to draw it. So long as I have my trusty tools, protractor, compass, once in a while you need a compass, and the ruler, and a little bit of understanding of the geometry, the rules of triangles, the lingo that goes with triangles. Okay, next one. Oh, Doug was trying to challenge himself. Okay, draw an equilateral triangle using only a ruler. Little bit challenging. Okay, side length. I've used 18 a lot, I've used 20 a lot. Have I used 22? I think I may have used 22 early on. Maybe let's say 22. No, I don't think I had. I had a 22.5-inch long side, a couple of them. But 22-inch, so I just want to do something different. And next I'm going to choose that the side lengths I want are 22.5-inch. And look what I'm doing. I'm taking my ruler and I'm gradually moving it down because I'm realizing, well, if it's equilateral, all three sides have to be that long. That's almost the full length of the ruler. So to make sure it's going to fit, okay, but that's not how I'm going to draw it. I want it to be correct. So 22 inches. There's the 22. 22 inches. Now what do I do? I know that an equilateral triangle always has three internal angles that are all 60 degrees. But I'm not supposed to be using my protractor. So what I'm going to do is I'm going to find the midpoint of that 22-inch side. I'm putting my ruler right back where it just was. And half of 22 is 11. So I'm going to put a little mark here at the 11 inch. Then I'm going to take my ruler and I'm going to take advantage of the fact that the ruler has all those little lines that allow us to, get the light from glaring on them, that allow us to measure things. And those lines, those little tiny lines, are all both parallel to this edge of the ruler and perpendicular to that edge of the ruler. So I'm going to try to draw a 90-degree angle right up through this 11-inch thing. And I'm judging by looking at those little lines and the line, my 22-inch line, trying to make sure that those lines are very parallel to the 22-inch. And then I'm going to draw a line longer than I think I need it, because I'm not sure how long this line would have to be to get all the way up to the vertex. But I'm pretty sure that's longer than I need it. And I can even say, put a little square there, point out that I just drew a right angle without a protractor. But I admit it would have been better if I do it with a protractor. I'm just trying to follow the rules, using only a ruler. Now I know the other two sides have to be 22 inches, so this suddenly becomes very easy. I get 0, or 0, that's 24. Ruler backwards. Get 0 on this vertex. And I swivel the ruler. I rotate the ruler around this point, which is the vertex. Geometry language comes in handy. Until I get the 22 to land right there on this line that I drew. And then I draw a line along there. And then I do it again over here. So 0, swivel, 22 inches. I don't want to just trust where that one was. I want to actually do the process again. 22, it's a little tricky. Well, it's probably because it's a chalkboard, the main reason it's tricky. There, I have it where I want it. I don't want it moving on me. I'm going to draw some of the line and then stabilize the ruler and then draw more of the line. That one a little crooked. Okay, 22 inches. 22 inches. And theory tells me that I have three 60-degree angles. I'm sort of ignoring that line. To follow my own rules that I like to follow, I should actually make that line a dotted line. So that you can see that whoever's looking at the drawing can see this line isn't really part of my drawing. It's not really part of my answer. It's a construction line. It's a it's a line that helped me draw the rest, which doesn't have to be in the final answer. If I wanted to, I could actually get an eraser and erase all of that. It would be tricky to erase, but I could do that. There'd be little telltale smudges, but I don't have to. I put a dotted line and people know, oh, it's dotted line, so it's not really part of his answer. And there's not very much time left, and that was my last example, except for the idea I had early on, to try to draw a triangle that is obtuse and scalene. So I have to think about that. I only have 4 minutes. I have to think about that. I consider this a success. obtuse and scaling. So I need an angle that's more than 90. But trying to make this easy on myself, I'll start with, say, a 20-inch line. I need to start with something. So I'll start with a 20-inch line. Now, any angle larger than 90. So I just want to go a little bit larger than 90 so that I obey the rules, but I don't have to draw a ginormous triangle that's hard to fit on the wall. So, how about a 95-degree angle? That's just a bit more than the 90, and it is obtuse. 95, is that going to make this harder or easier? I'm not even sure. Because to get it to be obtuse and scaling, wait. No, that's not what I wanted. Obtuse and scaling was too easy. That's what I did before, so I didn't write down my notes. Obtuse and not scaling is what. So I want one of the angles to happen twice, or one of the sides to happen twice, so that it's not scaling. So if I have a 95, 180 minus 95. Oh, well, actually, I may have found an easy way to do this. Let's see. Over 2 is equal to 180 minus 95 is 85 over 2, which is 42.5 degrees, 2 of them. So yeah, I think that is doable. The third one has to be 42.5. Double checking with the calculator. Learned his lesson yesterday. 180 minus 95 equals, divided by 2 equals 85, 42.5, yes. So I'm going to draw the 95 I already got ready. I'm going to draw the 42.5. 42.5 is about here. Straight edge. Make it nice and long, this line. It has to be much longer than that. That might do. And then this one, I'm in the way, I'm blocking the student's view of what I'm trying to show them. That's 95. This is 42.5. This should also be 42.5. So I have drawn an obtuse triangle that is not scaling, because 2 of the angles repeat. Let's measure them. I already know that's 42.5. I'm going to measure this one. And yes, I'm quite happy with that being 42.5. Let's measure these sides. Clearly this side's really long. That's 24 to there. That's about 28.5 inches. There's this one that I'm really curious about. Oh, that is very close to 20 inches. Well, we knew that would happen. We should have, I think all the students probably knew that was going to happen. This is 20 inches because I created an obtuse isosceles triangle. Is that the only way to obey these instructions that I didn't write down? Obtuse and not scaling. Is that the only way? I'm almost wanting to say, yeah, it must be the only way, but I'm not actually even sure. And I'm nearly out of time, so I'm going to just leave it to the students to think about that and let the dog say goodbye because it's their supper time, and she's probably sitting there thinking, when is he going to stop talking and bring me upstairs and feed me? Okay, come here, dog. Oh. Heavy little thing for someone who weighs, yes, what is it? 15 pounds. She seems heavy. Okay, we're saying goodbye. Thank you for letting me teach you geometry. It was fun. Drawing triangles. We should do that every week for the whole school year. I'm going to suggest that. And with that, I will say goodbye.